All right, guys, we're going to talk about compound inequalities and how we would solve them. And a compound inequality is just when you have more than one action happening in one inequality. So in this case, it's actually two separate inequalities, and we have the word or here. And that's going to be important as we're learning because there are or problems and there are and problems. And this was an or problem, so these are a little bit more straightforward. We're going to solve these the same exact way we would solve any inequality. So if I look to the left, I have 4x plus 1 is less than or equal to negative 11. And to solve that, I need to get the x alone. So I need to get rid of the plus 1. So I'm going to do the opposite operation. I'm going to subtract 1 on both sides. And when I do that, I'm left with 4x is less than or equal to negative 12. And then I have to get the x alone. So I have to get rid of the number that's with it. It's being multiplied by 4. So to get rid of that, I'm going to do the opposite, which is divide by 4. And I'm going to get x is less than or equal to negative 3. And then we have the or in the middle. Now moving on to the other side. I have 3x minus 4 is greater than 5. So I need to get the x alone. And so I'm subtracting 4. The opposite would be adding 4. Notice I'm always getting rid of what I call the lonely guy, the one that's not attached to the variable. I always get rid of that one first. And so that cancels out. I'm left with 3x is greater than 9. Now I have to get rid of the 3. Since it's multiplying by x, I would divide by 3. Now get x is greater than 3. So my solution is this. It's x is less than or equal to negative 3, or x is greater than 3. And when I graph that, let's make it blue. So if I'm going to graph this, I like to just put the two numbers. I have a negative 3 here, if you want to put a 0 in there, and a positive 3. If I'm going to graph x is greater than 3, it's an open circle because it does not include 3. It's not equal to. It's just greater than. And greater than would be all the solutions that are bigger than 3. So it go to the right. On the left-hand side, we have x is less than or equal to negative 3. And so from there, let's make this one purple. From there, I have a closed circle. Whoops. I have a closed circle at negative 3. And it's less than, so it's going to go like this. And the circle's closed because it's also equal to. And I like to actually write the word or in the middle. Because if it's an or problem, when you're done, you should have two separate lines extending down the number line, and there should be a space in the middle where you could put the word or. That's a compound inequality, but specifically an or compound inequality. Now, let's take a look at an and problem, okay? An and problem looks a little bit different. Let's see. I have this and problem. It looks like this. Negative 1 is less than or equal to 2x plus 3 is less than 7. An and problem starts off looking like this. And I'm going to write that here. It's an and problem. So I'm going to solve this as if this negative 1 wasn't here and it's just 2x plus 3 is less than 7. I would first get rid of the 3. So to get rid of a positive 3, I'm going to subtract 3, and I'll subtract it here. I'm also going to subtract it on the other side of the inequality. So make sure that when you subtract it from the middle and from both sides of the inequality. Okay? And now we're going to just do the math. And we have negative 4 is less than or equal to 2x, which is less than positive 4. You're not always going to get the same numbers there. That just happens to work in this problem. So next step, I have to get the the x alone. I need to get rid of that 2. So I'm going to divide by 2, and I'm going to divide it in all 3 places. Okay, the middle, the left, and the right. And now when I do that, make it another color. I'm going to get -2 is less than x. That cancels out, which is less than 2. Again, we have -2 and +2, but you're not always going to get that. You might have -1 and 5 or -1/2 and 13/2. So it doesn't mean that you're going to have the same numbers. This one just happened to work out that way. So when I make my number line, what I want you to be paying attention to is, first off, your numbers should work like they do on a number line. So the least number should be the furthest on the left. I'll put a 0 in here. And then we have over here, it's greater than or equal to 2. So we're moving in this direction. Over here, it's an open circle because it does not include 2. And it's less than. So it looks like this. And you're going to hear my Boston accent. We're going to have a bar in the middle. So an and problem is going to have the bar in the middle. If you notice right here, the x, it means the solutions to this fall between -2 and +2. And so that's an and problem, and it should be a bar, okay? So for an and problem, you're going to have a bar in the middle, and for an or problem, you're going to have 2 separate lines that extend down the number line, leaving a space in the middle for you to actually write the word or. And that's how it would work. One thing I want you to remember, though, is if you have to, let's say this was -2. When you divide everything by -2, you would have had to flip the inequality signs. You would have to flip these, because whenever we divide by a negative number, we have to flip the inequalities. So I just want to make sure you remember that as you're going along and working with inequalities. That's how we would do compound inequalities.